Are you able to hear me okay? All right. I'm delighted to be here. It's an unusual set of circumstances for a variety of reasons. I'm a professor of public health at the University of Illinois at Chicago. I've been there for 20 years. Prior to that, I was in the Department of Internal Medicine at the University of Chicago. But now I'm this bizarre chief scientist at this company. And the story of how this happened, I think, is pretty interesting, and you're going to get the story today. So this is what I'm going to cover. I'm going to cover the origin of this area of facial analytics that was developed by a colleague of mine, Dr. Carl Rixenick, and the linkage to a field of study called biodemography that I created back in 1992. I'm going to talk about human longevity and the predictability of human longevity, how we train computers to see like humans do, and I'm actually going to conduct an experiment on a volunteer. We're going to test his brain functioning live during this presentation, and then the practical applications of this new disruptive technology. So let's get to it. I'm going to start out with a description of what biodemography is, and it's going to be an area of science that many of you are not familiar with until I describe it, and then it'll be intimately familiar to you. Basically, what I'm showing you here is what's referred to in aging biology as the distribution of death. This is an illustration of the timing with which death occurs in humans. On the x-axis is age, on the vertical axis is number of deaths, and what you see here is a typical J-shaped curve. High early age mortality, the death rate always declines to its lowest point right at puberty, and then it rises exponentially thereafter. This is what death looks like for almost all sexually reproducing species, a J-shaped curve. Now, what's interesting about this is that the J-shaped curve has never changed. Death rates have gone down, we live longer, but the age trajectory of death is constant. It has never changed, and this constancy gives us a sense that we have an idea of where things are going to go for any population. It looks exactly like this everywhere in the world, and as it turns out, this J-shaped curve is fairly common among most sexually reproducing species. Looks exactly like that. Now, this is going to be a little esoteric, so this is going to be the brief dose of science that you're going to get in evolution biology. Forget all the words for the moment. What I've done is I've divided the duration of life of a species, humans, in this case, into three regions: the pre-reproductive region, the reproductive region, and the post-reproductive region. What my colleagues and I have demonstrated years ago is that the duration of life of humans and almost all other sexually reproducing species is calibrated to the window of time during which reproduction occurs. In other words, duration of life has little or nothing to do with how you live your life. It's easy to shorten your life. You can smoke cigarettes or do things that can shorten it very easily, but lengthening it is far more difficult. So let me repeat. Duration of life is calibrated to something that has nothing at all to do with how you actually live your life. It's calibrated to a fixed genetic program associated with growth, development, and reproduction. Now let me illustrate what that means and why it's important. This is a mouse. A mouse, for example, goes through puberty at 30 days. It lives for about 1,000. A dog, that was my dog, by the way, she lived for 5,100 days. They go through puberty at about 9 months. Elephants live about 26,000 days. Humans live 29,000 days on average, maximum of 45,000. We go through puberty at 11 to 12 years of age. A sea turtle goes through puberty at 50 years of age, 50, and it can reproduce for 100 years, live for 150 years. Bowhead whale can live for 210 years. It's a mammal, just like us. And last but not least, the Greenland shark. The Greenland shark goes through puberty at 150 years of age. It has to wait 150 years to have sex, but then it can have sex for 350 years because it can live for 500 years. So, repeat, duration of life is calibrated to the onset and length of the reproductive window. What am I trying to get across here? The constancy of human mortality. We know when people die. We know how long humans are capable of living. It is a highly predictable phenomenon. Populations are heterogeneous mixtures. Some are destined to die early. Some will die relatively early, even if they live a healthy lifestyle. You might recognize Jim Fixx, the person who basically invented running. And then you get people like this who can adopt very unhealthy lifestyles and still live exceptionally long lives. In fact, the world record for human longevity was by Jeanne Calment from southern France, who lived for 122 years, and she smoked for 100 of them. It's not a license to smoke, by the way, for you guys, just so you know that. Most people that smoke will tend to die earlier. So my colleague, I ended up hooking up with a colleague in facial analytics for reasons that are going to be obvious in a moment. But facial analytics is nothing more than the study of the human face and attributes of the human face. And the linkage between what I do in longevity and what he does in facial analytics is what ultimately led to this company called Lapetus. It was completely serendipitous. So let me explain what this is. Several years ago, my colleague and I were collecting data on older individuals, and a reporter from the Washington Post got wind of what we were doing. So she wrote a story in the Washington Post that made the front page of the Washington Post, and we decided to collect some data off of this. So our goal was to collect 10,000 images from people who would provide us data that we could actually use for research. Well, as it turns out, once this story went public, it went viral. I don't know if any of you, uploaded your facial image to Face My Age. We were the creators of Face My Age. This was mimicked by Microsoft a year later. And basically, this whole process went viral. And my colleagues and I have now, there have been dozens and dozens, hundreds of stories that have come out about the work that we had done, the research that we've completed, and where this is all headed. This is just a very small sampling of some of the work that has come out and then the technological advances that have resulted. So let me just get by this and get to some of the meat of this presentation. When this story went viral, we were contacted by quite a group of entrepreneurs who came up to us. Remember, we're just research academics. We are not business people. And they came up to us and said, "You guys have any idea what you just did?" And of course, our response was, "No, we haven't a clue." I mean, we collected 2 million images when we thought we were only going to collect 10,000. They said, "No, you've actually completely disrupted several industries, one of which is the life insurance industry. But actually, as it turns out, we now know we've disrupted more than one industry with this technology." Lapetus was born as a result. Lapetus is the Greek god of mortality, in case you were wondering where that came from. Basically, what we've done is we've trained computers to do what the human brain does automatically. The human brain is actually a remarkable machine. And you can actually train computers. I mean, that's what machine learning basically is all about, training computers to do exactly what the human brain already does. One of the things it does very effectively is identify gender. It can identify age, health status. There's a whole suite of things that the human brain is capable of doing, and doing it very effectively. This is the gentleman, Bob Ben-Moshe. He was the former CEO of AIG. He's the one who convinced me to take the science of aging biology and bring it to bear in the world of life insurance, health insurance, and basically health in general. And this was the image that got his attention. He actually invited me to give a presentation at his meeting, at one of his meetings in Texas. And this is the picture that got his attention. The gentleman on the right, how old does he look? I can't see anybody in the back, but those of you in the front, how old does he look? Mid-50s. Right, mid-50s. Is that what you said, by the way? 65. You said what? 65? Did anyone say 55? Most people would say he looks like he's in his 50s. As it turns out, he's 70 years old. That's his father on the left side. His father is a centenarian. Those of us that study aging for a living see this all the time. Almost all of the children of centenarians, of long-lived people, look young for their age. Why do they look young for their age? Because they are not that age. Chronologically, they may be 70 years old, but biologically, they are actually much younger. And as it turns out, these individuals that look young for their age tend to live significantly longer than those who may be the same chronological age and look older. Fairly easy to document. We can actually observe the duration of life of these individuals. So I'm going to conduct an experiment on this gentleman who I found a volunteer before I was presenting, and we're going to show you how his brain works, which hopefully all of you will come to the exact same conclusions. We're going to start out with gender detection. So he's got a microphone, and I hope that's on. So what I'm going to ask him to do, I don't care if you stand up or sit down, I'm going to show an image of a face with all the information stripped away that it would allow you to detect a person's gender. And I want you to give me an instantaneous response. Just say male, female, in this case, and then we'll verify it, all right? Say again? Just say male or female. That's all you got to say, male, female. Come on up stage.
Thank you.
You can see.
Yeah, it was probably better.
All right, so I'm looking for a quick response.
All right. Female.
Correct.
Female.
Well, no, it's the same one.
All right.
That's the confirmation.
All right.
Just give me the first one.
Male.
Correct.
Male.
Correct.
Female.
Correct. How did you do that?
Sorry?
How did you do that?
Visual reflexes.
All right, that's exactly what I wanted to hear. So the human brain is hardwired to detect gender. It's remarkably effective. Wait, I got a couple more experiments for you.
All right.
So let's try this one, age detection. This is pretty easy. Which one's older?
One on the right.
One on the right. How do you know that?
She looks older.
That would be true. Now, of course, what we have done is we have taken computers, we've trained them on your eyes, and I know exactly which part of her face you're looking at to determine age. Which one is older?
One on the right.
Trick question. They're both 70. So the story here, by the way, is that when you have individuals like this, and remember the other one was the 70-year-old son of a centenarian, when you have people like that on the right that look much older but are the same chronological age, definitively we know they tend to die earlier than those that tend to look younger. What is that telling us? The face is a biomarker. It's one of many biomarkers that we've now used. Wait, I don't think we're done yet. We may have one more. Well, BMI, you don't have to answer that one. We can use the face to actually calculate BMI. So if somebody's telling you they're given height and weight and they're lying, we'll know it.
What if?
Yeah, no, I wasn't asking you to. But try this one, though, smoking detection. So here, as it turns out, when you smoke cigarettes, it writes a signature on your face. It's permanent. I'm sorry. But if you quit smoking 10 years ago, you still have that signature on your face, that smoking signature on your face. Plastic surgeons, can see it very easily. I'm going to show you identical twins, one of whom smoked and one of whom didn't. And I want you to just tell me which one is the smoker.
One on the right.
Yeah, you hesitated. That one, that's the easiest one. It gets harder.
One on the left.
Correct.
One on the left.
No, the one on the right. Try this one.
One on the left.
Yes. Now, just tell me, this last one that I showed you, why did you come to the conclusion that she's the smoker?
Because her...
You see wrinkles on her cheek.
Yeah, yeah.
Okay.
Okay.
All right. Thank you so much. I appreciate it.
No worries.
So he did great. I presume your brains were functioning as well as his, and you concluded, for example, that in the lower right-hand corner, that the one on the left is the smoker. Well, guess what? We know exactly what lines are drawn on the face by smoking. We can train a computer to identify it. We've done it, and it works successfully. So it's not actually that difficult. And insurance companies have actually developed quite a bit of interest in this technology. I don't actually have much time left, but you can actually use the face to identify a broad range of diseases. We're in the process of traveling across the globe, collecting ground truth data on faces across the globe, linking them up to other attributes of individuals. We're also collecting videos. We're using information from the eyes to detect certain neurological conditions. And we are, of course, this is done very systematically. We're research scientists, so we're very good at collecting data systematically. And let me show you this one last video to illustrate how this technology has actually already entered the market. It is now being used by a couple of insurance companies. This one, I think, is Legal & General. And what I'm trying to tell you is that the entire process of underwriting for life insurance, as an example, should take about 3 minutes. If you've been underwritten for life insurance before, you know it takes about a month. Somebody comes and draws blood, they measure your height and weight. It does not have to be done this way. It is a 3-minute process. Watch how it's done. And I'm done after this, by the way. No rush. Incidentally, my preference was to run it live for people in the audience, but I wasn't able to do that far enough in advance. The process is done. Somebody can actually be underwritten for life insurance. You key in small pieces of information about yourself, date of birth, age, gender. The one thing I will remind you, because I know somebody's going to ask me this question, you are not being underwritten based on your face. The face is only, at the moment, being used to detect fraud. Whether or not, people tend to lie when they apply for life insurance. They might say that they're a non-smoker when in fact they are a smoker. And there is a blood test that can be done which can be easily fooled by simply not smoking for a week before you actually have the test done. The face is basically being used to determine whether or not you're providing accurate information on your body mass index and smoking status, and all of the other information is being used to underwrite you. The information I provided early on was a way to suggest that it's not that complicated, that I know that there's a tendency to move towards big data. The conclusion that we've come to is that less is more. We've narrowed it down to about a dozen questions, and that is all that is needed to assess risk and place people into risk pools, where previously it would take a month to do this. So we're anticipating this is the way life insurance will be underwritten in the future. And I think I'm going to stop there and open it up for any questions.
I've got quite a few questions.
Yeah, sure.
And I'm going to kick them off, actually. Photoshop.
Yep. Easily detected. Photoshop, makeup, plastic surgery.
But if there's a picture of me that I want to upload, one from broadcasting in the studio, on that little lovely model you've said.
We won't accept it. It has to be a live capture. So you have to have your phone or whatever it is that you're using. You do a live capture, a photograph. That photograph.
So what if I'm in bed in the morning and you're saying at any one point in time it has to be a live capture? Live
capture. Yeah. Do you want to send us a picture of you in bed in the morning?
It's not the most nicest thing to see, to be fair, but
we don't want you to wear makeup either, and you don't smile.
How can you tell, though?
It's easy to detect. You can train computers to do just about anything, and makeup is one of the easiest.
Okay. Really not detecting, so I heard a couple of people went, really? Like, you can't detect somebody not smoking for a week? We were among health professionals, by the way, and it was like, really? True?
Yeah, the blood test is easily fooled just by not smoking for a week.
There you go, in case you want to fool it. And the other thing I wanted to ask you was, mind overload on this one. What can you tell from my face right now? How old do you think I am?
25.
Why are you laughing?
Hey, look,
why are you laughing?
Think I haven't been asked that before?
Now.
I mean, come on.
I'm offended. Did you hear the roars of laughter? How old do you think I am?
Look, I learned a long time ago not to make that mistake.
No, I'm being genuine here. I mean, give me your honest assessment of, because I'm just trying to gauge from what you've just delivered. There's a serious point to what I'm about to
33.
33, okay. You think I'm 33. What do you know about my lifestyle from looking at my face?
Nothing.
So, am I a smoker?
No, I'm the longevity expert. I'm not the facial analytics guy.
All right, so when am I going to die?
So, do you really want to know the answer to that?
Sure. Yes.
No, actually, let me ask you seriously, and the audience seriously. If I could actually tell you your date of death, would you want to know it? Honestly, there's very few people that want to know the answer to that question.
You know, the reason I'm putting you on the spot a little bit here is because you did that with Azar, and you said to him, you know, who smokes more, who doesn't, you can tell from the pictures. So I was trying to sort of say the same thing in terms of that model that you've used. If you're looking at me right now and you're saying, well, you know, what can you tell from me, like you were asking Azar to maybe tell from some of those screen captures?
One of the pictures, one of the images that I removed from my presentation was an image of what the computer sees versus what we see. So I see, you know, smooth skin. Huh. If a computer is looking at your face, it might identify these vertical lines right around your lips that I can't see, or maybe that you're hiding with makeup,
right?
that I can't see. So the computer is much harder to fool than me.
Fascinating talking to you. I'm going to open it up to the floor for questions. Anybody want to ask Jay a question about anything you've seen on this presentation? Gentleman just there in the front. Anybody else? Give me a second question would be great. Trying to just see. Wave your hands at me madly if you want to.
Just curious how common it is to have a disparity between chronological age and biological age, and is there an impact of that on the machine? Yes,
great question. So it's actually one of the reasons why I didn't want to answer her question. So because we did an interview, I think it actually was with a BBC reporter, and we had her upload her photograph. And actually, any of you can test this out. You can go to selfiequote.com. You can upload a photo, and you'll get a pretty quick answer. So most of the population will get an answer that's different than their current chronological age. About half will be older, half will be younger. In that BBC interview that we did, she came in about 5 or 6 years older, and she was angry with us during the rest of the interview. So I learned not to do that. But yeah, most of the population is above or below, and the general philosophy is that we know exactly what kind of changes occur to the face in each decade of life. I'm 64, so I know jowls begin to appear right about the age of 64, sure enough. That's exactly what's happened. So we know what those changes are, and they're measurable and observable. But people will age at different rates, and part of that can be influenced by lifestyle. Smoking is really a bad thing for accelerating aging of the face for sure, but other components of the body as well. And I would point out, by the way, because I heard some of the previous speakers, especially one of the speakers who was talking about leprosy. So really, I assume you can see where this technology is going, right? Because you can now take your phone, and you could take this to some part of the world where there isn't medical technology easily available, and we're on the verge of developing sensory analytics technology that will allow you to photograph that individual, perhaps photograph parts of the body that might have damage to it. We'll have a sensor that you could plug in here, you blow into it, and you could probably detect about 20 diseases from the breath and about 12 diseases from the photograph. So that's where this is all headed. Right now, we've just brought this to the world of insurance, but this is really all headed towards medical applications.
Okay. Thank you. Anybody very quickly, because I think I took up some of the time there, with a question? Can't quite see here. Jay, thank you. We really appreciate it. I'm not 33, but thank you for saying so.
Well, are you going to tell us what the answer is?
We do have a question here.
Oh, we do. Yeah, let's have one, because you saved me answering that question.
I'll save you answering that question.
That's
the only reason I was waving.
I'm happy to answer.
I spend a lot of time with the insurance sector, both with incumbent players and the startups that are looking to gain access to it. And I've actually did a trial on that similar tech at an InsurTech conference last year. And it was almost right. I was a bit older, a bit younger than it said I was, but I used to smoke, so maybe that's it. I'm just interested, what are you doing within your research to help people to understand how they can change their longevity? What value can someone derive from having an understanding of how old they are? And are you doing anything to help them to enhance their longevity through your studies?
Yeah, so that is a perfect question for a variety of reasons. And what we've done is we've created an application called Healthy, H-E-A-L-T-H-E, advice. So when you answer all of these questions, if you provide information indicating that you have a negative risk factor, like you smoke, or you only get 5 hours of sleep per night, or you're obese, we know precisely what those levels are. We've calculated what the gain in longevity would be, what the gain in healthy life expectancy would be if you alter your lifestyles in specific ways to bring those levels up to more favorable levels, and you get an instantaneous feedback telling you how much longer you will live and what the probability is of surviving to any subsequent age that you choose if you adopt a healthier lifestyle. And I would point out, by the way, that one thing I didn't show you was a process called age progression. So we can upload a photograph of you, show you what you'll look like 10, 20, 30 years into the future if you adopt a healthy lifestyle versus an unhealthy lifestyle. It's perfect for kids, for teaching kids what they shouldn't be doing in terms of unhealthy lifestyles, but it's great for adults as well.
Okay.
And you owe us an answer.
Don't have to if I don't want to. Thank you so much for your question. Appreciate that. Jay, thank you. Thanks so much.